All right, everyone. So in this video, we're going to review how to solve a system of equations using elimination. So if you remember what this word eliminate means in math is we want to get rid of or cancel, right? So if I have something like 5x, if I want to cancel that term, I could just do minus 5x and that will cancel. Or if I have negative 3y, I could do plus 3y. Those will cancel. So we do this by using two important properties of equations. So the first one is that we can add equations together. So if I add everything on the left, 10 plus 2 plus 3 would give me 15, and 10 plus 5 would also give me 15. So if we add equations together, they remain true. And the fact that we can multiply both sides of equations. For example, if I do times 2 here, I would get 20 equals 20, which is correct. But we have to be careful because I have to multiply every term. Because if I just do this, times 2, well, 4 plus 3 is not equal to 10, right? So we have to multiply everything, including this 3, right? Because then 3 times 2 gives me 6, so 4 plus 6 is 10, right? So we just have to be careful when we're multiplying both sides. We have to multiply every single term. Okay, so using these two, we can solve systems. So if I look at this first one, it should be easy if the opposite pair is already there, right? Because if I notice I have 2x and minus 2x, so if I were to add these two equations together, so I put my plus sign, these would cancel, right? Y plus 2y gives me 3y. 5 plus 7 on the right side gives me 12, right? So I could divide both sides by 3 and get y equals 4. Okay, but remember, we always need x and y. So once I have a variable, I need to go back and plug it into either of the original ones. So if I choose this first one, so 2x plus, so instead of y, we could put in 4 equals 5. Then I could minus 4 on both sides. 2x equals 1, divide by 2. So x would be 1/2. So my solution would be x comma y, so 1/2 comma 4. Okay, so you can see it's pretty simple, or it should be pretty straightforward if the opposite pair is already there. But it's not always going to be. So if I look at number 2, well, I see a 2x, and so all I would need to this bottom one to be is minus 2x, right? So if I have negative 2x, that would cancel, right? So I can use my property that I can multiply the entire equation. So in this case, I just need a negative or a negative 1, right? So if I do the entire equation, that would give me a negative 2x minus 3y equals negative 4. So basically, you make every single term negative. Okay, so if I copy over this top one, now the opposite pair is there. So if I add these together, these cancel. So negative y plus a negative 3y is a negative 4y. Okay, and 12 plus negative 4 is 8. Okay, so if I divide by negative 4, we get y is negative 2. Okay, so I could go back and plug that in. So if I choose the first one to 2x minus, so y is negative 2. Okay, so this becomes plus 2, right? Minus a negative. So to undo a plus 2, I can minus 2 from both sides. So I get 2x is equal to 10. Divide both sides by 2, so we get x is 5. So my x is 5, my y is negative 2. Okay, so sometimes we could get away with just needing a negative, but sometimes we might need to multiply by a number. So to look at number 3, well, if I think about how to cancel, if I have a 3x, I would need this to be a negative 3x. Okay, so that's doable. But on the y's, I can't multiply anything. I can't bring the 2 up to a 3 without multiplying by a decimal, because if I multiply by 2, 4 is too big. So I would have to multiply both of these. So I think the x would be easier here. So if I multiply this top equation by just negative 3, that would give me negative 3x. Negative 3 times 2 is negative 6y, and negative 3 times 6 is negative 18. All right, so I can add these two equations together, so these will cancel. So 3y plus negative 6y is negative 3y. Negative 6 and negative 18 gives me negative 24. Okay, so divide both sides by negative 3. Y would be equal to 8. Okay, so let's go back and plug that in. So if I choose the first equation, so x plus 2, so y we now know is 8 equals 6. Okay, so 2 times 8 is 16. Okay, so to get x by itself, I just need a minus 16 for both sides, so x would be equal to negative 10. Okay, and I'll write this, so negative 10 comma 8, so x comma y would be my solution set. Okay, so sometimes there might be an easier variable to eliminate. Sometimes you have the choice. If you want to try another one, there's one over here. The answer, you should be getting that as your answer. All right, let's do one last one. So if I look at this one, now I can't multiply the 2 up to a 3 without a decimal, right? And I can multiply the 3 by something to get it to be 4, once again, without a decimal. So in this case, looks like we have to multiply by both. Okay, so we want to choose the least. So if I look at 2 and 3, we want to choose the least common multiple. So if I look at the multiples of 2, so 2, 4, 6, 8, and multiples here would be 3, 6, 9, 12. So it looks like the least one we could get them both up to would be the 6. So we could, if we want to multiply the 6, multiply the 2 and 3, we could get them both to be 6. So 2 times 3 would give me 6x, and 3 times 2 would give me 6x. Okay, but we need one of them to be negative, right? If this is 6x, I need negative 6x, so we could do a negative 3 here. Okay, so 2 times 3x is 6x, 2 times 4y is 8y, and 2 times 11 is 22. Okay, if I multiply the bottom equation, we get negative 6x plus 9y, negative 3 times negative 4 is a positive 12. Okay, so it's not too bad because it's lower numbers here, but multiplying both is sometimes necessary to get that pair there canceling. So 8y and 9y is 17y, 12 and 22 is 34. Okay, so if I divide both sides by 17, we should get y is 2. Okay, so picking either of the originals, we'll just stick with the first one. So 3x plus 4. So now that I know y is 2, we can go ahead and plug that in. 4 times 2 is just 8. Okay, so minus 8 on both sides. We get 3x equals 3. Divide by 3, x equals 1. So my solution would be 1, 2. Okay, so this is just a quick review of elimination. But there's another one on the right to try. If you want to practice multiplying both, you should get 4, 5 as your answer if you want to test that you're able to do that. But that's all for now.